Good morning, students. We are going to take up the chapter Surface Chemistry, which is Unit 5, and here we start with the introduction of the chapter. Surface Chemistry. It is the branch of chemistry which deals with phenomena that occur at surfaces or interfaces. Now, what do you mean by surfaces or interfaces? Surfaces or interfaces means boundary separating two faces, and faces means form of matter such as solid, liquid or gas. Now, here in this picture you can see solid state separated from a liquid state. So, the major part of the solid state forms the bulk of the solid, and this is the surface. Here you can see the liquid state separated from the gaseous state. So, the major part of the liquid state forms the bulk, and here we have the surface. So, bulk phase is the major part of any phase. Now, we move on to the next definition, that is adsorption. Before we go into the definition of adsorption, we can see this picture. Here we have the term absorption, which you are aware of. Absorption means molecules are drawn into the bulk of the phase, and adsorption means molecules adhere to the surface of the phase. So, now we are going to define the term. It is the phenomenon of attracting and retaining molecules of a substance on the surface of a liquid or solid, resulting in higher concentration of molecules only on the surface. So, whenever we define a term, we need to see the keywords. Here the keywords are attracting and retaining, where on the surface of a liquid or solid, and what it results into. It results in higher concentration of molecules on the surface. Now we move on to the next topic, that is the examples of adsorption. Here you can see raw sugar which is yellow in color, and here you can see pure white crystals of sugar. Now, how do we get this pure white crystals of sugar? Actually, we add animal charcoal in activated form to raw sugar. So, raw sugar loses its yellowish color when mixed with activated animal charcoal. And animal charcoal, you know, it is a black porous material and is obtained by charring of animal bones. Now, activated charcoal means it is that form of charcoal which is highly porous and is obtained by heating charcoal to high temperatures. Here you can see the example of absorption, where a sponge is absorbing water, and here you can see decolorization of a colored solution containing impurities using activated charcoal. The activated charcoal adsorbs the colored impurities and it settles down and the solution has become clear. Here you can see the picture of activated carbon or activated charcoal which is highly porous. Here we have silica gel which is a very good desiccant or dehydrant, and you might have seen the silica gel pouches which are kept in newly purchased water bottles, flasks, medicines or in electronic items. This is to adsorb the moisture and keep it dehydrated. Next we come to the terms adsorbent and adsorbate. Now the picture itself helps you to define the terms adsorbate and adsorbent. Adsorbent provides the surface to get accumulation of the adsorbate. So now we define adsorbate. It is a molecular species which concentrates or accumulates on the surface. And adsorbent we wrote inside the circle. So, it is a material on the surface of which adsorption takes place. Now, we know adsorption is a surface phenomena. So, solids will act as good adsorbents because in finely divided state they have large surface area. Now, few examples of adsorbents are charcoal, silica gel, alumina gel, clay, colloids, metals in finely divided state. Next term is desorption. Now, from the picture it is clear that desorption is opposite of adsorption. It is reverse of adsorption. So, it is the process of removing an adsorbed substance. Now, how can we bring about desorption? It is brought about by heating or by reducing the pressure. And it is useful because it makes a surface available again for more adsorption or reaction. Now, we come to the distinction between adsorption and absorption. Both adsorption and absorption can take place simultaneously also, and in that case we use a common term, that is sorption. Now we look into the differences of adsorption and absorption. First point of difference will always be the definition of the two terms. So adsorption is a process in which substance is concentrated only at the surface and does not penetrate to the bulk of the adsorbent. And absorption, a substance gets distributed uniformly throughout the bulk of the substance. Second point of difference is concentration of adsorbate is different on surface and in the bulk, and in absorption concentration of adsorbate is same throughout. The third point of difference is very easy. Adsorption is surface phenomenon, absorption is bulk phenomenon. Now, whenever adsorption takes place, once a layer is adsorbed, the availability of the surface decreases. So, it is rapid in the beginning and its rate slowly decreases. Absorption on the other hand proceeds at a uniform rate. And examples, water particles are adsorbed by silica gel and water particles are absorbed by anhydrous calcium chloride.